Now let's look at paper 3. This is the example that I have shown you on the other day. So let's look at the question. You are required to carry out an experiment to investigate the relationship between the mass of water and the extension of a rubber band. Okay, the extension. So, in paper 3, you really need to carry out an experiment. Okay, so diagram is given. Okay, you need to carry out the experiment by using the steps below. Okay, so you need to arrange apparatus by hanging an empty bottle to the rubber band as shown in diagram 1.1. You need to measure the initial length of the rubber band. Okay, L naught. So means that after you hang it, okay, you need to measure the length. Okay, with a meter rule. Okay, so from the question you can see that this is the two physical quantity that we are going to look at. Okay, then you fill 50 grams of water into the empty bottle and record the length of the rubber band. Okay, L as shown in diagram 1.2. So you fill in water, then you measure the length of the rubber band. Okay, so you can assume that 1 centimeter cubic equals to 1 gram. Okay, you need to record the value of L in a space in 4B. Okay, this is a question for 4B. Then you are going to repeat step 1 and 2 by using the masses of water 100, 150, 200 and 250. So just now you start with 50. So you see that you got 1, 2, 3, 4, 5. Okay, 5 different value of mass. Okay, so after you do the experiments, okay, you need to answer the questions. And don't forget, okay, to jot down your value of L, okay, with different mass. Okay, let's look at the question. Okay, based on the experiment conducted, you are required to state the manipulated variable and the responding variable. So this one you can find from the questions. Okay, just now already told you, okay, in this question we are looking at two physical quantity. Okay, the mass and the extension. So how to determine which one is the manipulated and which one is the responding? Okay, you can see from the question. Okay, you are asked to measure something. So the one that you are measure, okay, and record, okay, usually is the responding. Okay, then, okay, something that you determine. It's not you determine. Okay, you are the one, okay, that keep changing the value. Okay, so you see, you repeat the step with the 50 gram, 100 gram, okay, and so on. So means that mass will be the manipulated variable. Okay, then next. Okay, calculate the extension of rubber band X by using the equation below for each length of rubber band. So you have extension X equals to L minus L naught. Okay, so the L, okay, is the L that you get, okay, from your measurements, okay, after you use different values of M. Okay, then the L naught is the one that you measure from the beginning. Okay, so you get X, okay, X equals to L minus L naught. Okay, so you calculate for 5 different mass. Okay, then you're going to tabulate the value of L, X for each value of M in the space provided. So means that in your table you should have at least 3 quantity. So, okay, is it okay? I want to put the L minus L naught inside the table. sure, but it's not necessary, okay, because the question only asks for 3. So we have, okay, remember we should start with the manipulated variable first. So the manipulated is m, okay, m, okay. Is that okay to be write the m only, or must I write the full name for the quantity, the mass of water? Okay, both is accepted. You can write m only, or you can write, okay, the mass of, okay, mass of water m, like this also okay. But okay, you must write the unit. Okay, if you don't write the unit, I'm sure that you will lose your mark. So the mass, sorry, it's not kg, it's g only, right? So okay, the unit will be g. Okay, so this is the first one. Then we have L. Okay, the L and the unit cm, and x also cm. Okay, so you got 50, okay, 100, 150, 200, and 250. Okay, when it names a table, make sure that it's a table. Okay, please use ruler to draw your table. Okay, this is a bad example, okay, because I don't use a ruler, but okay, when you answer your question, please use a ruler. Okay, so you need to write down, okay, the value that you get from your experiment. And this one, okay, don't forget that is calculation from this formula. Next. Okay. On the graph paper provided, plot a graph of x against m. So you have a table of x against m. Okay, remember that. Okay, always, okay, when the question give you a title of graph, it will be y versus x. So your y will be your x, okay, there is the extension, and x will be your mass. Okay, in the example, okay, both x's are written, so you just need to mark and determine the suitable scale. Okay, then you plot your graph and get the best fit line. Okay, again, please use ruler to draw your line, and please use pencil to plot your graph. Never use pen to plot your graph. Remember that. Next. Okay, based on the graph, state the relationship between x and m. So if your graph, okay, is a straight line graph, okay, passed through the origin, then you can say that, okay, extension is directly proportional with mass. Okay, if your graph, okay, cut somewhere else, okay, with a value of c, okay, you can say that if it's a straight line graph, okay, you can say that, okay, the extension increase linearly with m. Sorry, with the mass. Okay, just something like that. Okay, remember that when you plot the graph, okay, the relationship, okay, will not be something like when extension increase, the mass increase. Okay, that one we will use for the relationship with our graph. So when we have the graph, okay, if a straight line, okay, it can be either, okay, directly proportional, or it's increased linearly, something like that. Okay, then, okay, calculate the gradient. Okay, to calculate the gradient, okay, remember, okay, you must draw a triangle. Okay, please draw a large triangle. So how to get the best triangle? Okay, you can find from the upper side. Okay, and then please don't get something that the line in the middle one. Okay, get some line, okay, exactly at the cross. Okay, something like this. Okay, you see that the line just cross it. Okay, so you get something like this. Okay, draw a triangle and then okay, something like this. Okay, you make a triangle and then you get the coordinate. Okay, then you calculate. Okay, so for example, this is my triangle. Okay, again, please use ruler. Okay, so this will be my x1 and y1, and here will be my x2 and y2. So gradient will equals to y2 minus y1 over x2 minus x1. Okay, do I need to write the unit? Sure. Okay, in the calculation, okay, you can ignore the unit first. Not ignore lah, but you didn't write first. But then when you get the final answer, you must write the unit. So what should I write if I don't know the unit for the quantity? Okay, it's easy. Okay, so you see for y the unit is cm, and for x the unit is g. So you just need to write the cm over g. Okay, this will be your unit. Okay, must write a unit. Okay, after calculate the gradient, okay, then okay, the last question, if rubber band is added parallel on diagram 1.2, what will happen to the extension of the rubber band? Okay, so this one you need to make prediction. Okay, if you really don't know the answer, okay, so you can guess, okay, to the extension. So for the extension, it can be only increase or decrease, right? So if you don't know the answer, you just guess, okay, whether it's increase or decrease. Okay, never leave it empty.